Tesla was the first company in the world to introduce the Giga Press into its manufacturing process, an idea that seemed pretty wild at first. But Elon Musk's bold decision turned out to be a real breakthrough, placing Tesla way ahead of its Chinese rivals by making EV production something that can be measured in seconds. But as we all know, if something exists in the world, China will eventually find a way to have it too, sometimes even better. When Tesla started using the 6,000-ton Giga Press to mold the rear underbody of the Model Y, China responded fast with a 7,000-ton casting machine. Then, when Tesla rolled out its 9,000-ton press to create the Cybertruck structural frame, China hit back with a jaw-dropping 16,000-ton Giga Press, the biggest casting machine the world had ever seen at the time, developed by XPeng. But the race between Tesla and Chinese EV makers is far from finished. Not long ago, Elon Musk revealed something massive, the EA Press 50,000-ton machine, crafted specifically for Tesla's upcoming generation of vehicles. It's the world's first casting machine that can shape at least 5 vehicle frames in a single go and build a whole car in just seconds. The internal mechanics and functionality of this beast are beyond incredible. So how will the 50,000-ton Giga Press outmatch China's 16,000-ton giant? Could this be Tesla's next major leap? Let's break it down. It's not hard to see why Giga casting tech is gaining so much popularity. Every car company wants to make electric cars faster and for less money. No one wants to fall behind, not even Chinese EV makers. What many people don't realize is that the car's chassis is the second most expensive part after the engine. It's a critical piece that affects a vehicle's structure, strength, and performance. It includes the suspension, steering system, and other key parts, making its production complicated and expensive. That's why for any carmaker trying to save money, improving the way the chassis is made is super important. As a leader in adopting Giga Press technology, Tesla is already using its 6,100-ton and 9,200-ton machines to speed up production of the Model 3, Model Y, and Cybertruck. These giant presses can create large, single-piece parts that replace dozens of smaller ones that used to be welded together. Take the Model Y. Tesla managed to lower production costs by nearly 40% by swapping about 70 smaller parts for just 2 big castings and a structural battery pack. Because of the Giga Press, Tesla's Shanghai factory can now roll out a Model Y every 33 seconds. Sounds unbelievable, right? With proven success on the Model 3, Model Y, and especially the Cybertruck, it's no surprise Tesla wants to apply this game-changing tech to its next-gen cars like the Cybercab and the affordable $25,000 model, widely known as Model 2. These vehicles have a simple design with tight front and rear ends, which makes them perfect for full underbody Giga casting. However, in real-world tests, even the 9,200-ton press, Tesla's strongest so far, isn't powerful enough to fully cast the underbody in one go, even for a smaller car. That's exactly why Elon Musk decided to take things to a whole new level. Tesla is going ahead with the 50,000-ton Giga Press, and fast. As Elon put it, maybe we just need to go bigger with these casting machines, like way bigger. So yeah, 50,000 tons it is. They have to shoot molten metal into the mold, then cool it down super quickly, really quickly. Musk said it might even produce a car in less than 5 seconds. Imagine that, a complete vehicle coming off the line in under 5 seconds. That's just wild. When compared to the 16,000-ton Giga Press, a 50,000-ton press offers more than 3 times the clamping force. That brings up some big questions. Just how massive is this machine? How long will it take to set up? And what makes it better than the 16,000-ton version? A lot of people still think the numbers, 16,000 tons or 50,000 tons, refer to the weight of the machine, but that's totally wrong. Those figures actually show the clamping force the machine applies, not how much it weighs. From what we know, most of the Giga casting machines used in China come from LK machinery. Interestingly, Idra, the Italian company supplying Tesla's current Giga Press machines, is now also under LK's control. Take XPeng's 16,000-ton hypercasting machine. It delivers a clamping force of 160,000 kilonewtons, strong enough to create large parts like front and rear vehicle underbodies. This system is used in the production of the XPeng P7 Plus, and it has helped reduce thousands of small components to just two main parts. Now imagine the jump to 50,000 tons. Tesla's new press will generate an insane 500,000 kilonewtons of clamping force, over 3 times what XPeng's machine delivers. At this level of force, Tesla could die-cast the entire underbody of a Model 2 or Cyber cab in a single press. More clamping force also means the ability to use bigger molds filled with more molten aluminum, making it possible to create thicker, larger, and more complex parts in one shot. It's hard to say exactly how much these machines weigh because official numbers aren't available for the biggest models yet. But we can make solid estimates based on earlier versions. For example, the 6,000-ton Giga Press weighs about 430 metric tons, that's nearly 950,000 pounds. The 9,000-ton model probably weighs around 688 metric tons or about 1.52 million pounds. That means XPeng's 16,000-ton press likely weighs at least 1,200 metric tons, around 2.6 million pounds, and takes roughly 120 days to assemble fully. Following that trend, the 50,000-ton Giga Press could weigh close to 8.16 million pounds. That's hard to imagine. When it comes to physical size, the 6,000-ton Giga Press is already massive, about 64 feet long, 20 feet wide, and 17.4 feet high. So the 50,000-ton version is going to be huge. Early guesses say it could be around 131 feet long, 42 feet wide, and about 39 feet high. That's about the size of a 3- or 4-story building lying on its side. Tesla might need to build an entirely new facility with strong concrete foundations just to support this monster. The machine will likely take up to 6 months to fully set up. Even with all that power, the way the machine works isn't that different from the 16,000-ton press. The process starts with material preparation. Tesla melts down new aluminum ingots and leftover aluminum from previous uses in a furnace heated to around 850 degrees Celsius. There are usually 2 furnaces, one gas-fired for melting and one electric to keep the molten metal hot between 750 degrees Celsius and 850 degrees Celsius. The space in the holding furnace is filled with nitrogen gas to stop oxidation and keep the temperature steady. Argon gas and a silicon carbide filter are also used to clean the aluminum by removing impurities and particles larger than 25 microns. Next comes mold preparation. Before each casting cycle, the mold is sprayed with about 35 milliliters of soybean oil to help release the part later, kind of like non-stick spray for baking. Then a vacuum system removes any air from the mold, and molten aluminum is transferred to the injection chamber. A high-speed piston, also oiled with around 8 milliliters of oil before each shot, injects the metal into the mold. Once inside, the metal solidifies, and the finished part is removed while still at about 400 degrees Celsius. It's then cooled rapidly down to around 50 degrees Celsius in a water tank. This fast cooling reduces flaws and makes the part stronger. The mold is then cooled to about 185 degrees Celsius and cleaned by a robot, getting it ready for the next cycle. Typically, the next casting starts 1 to 2 minutes after the previous one ends. To make this rapid pace possible, Tesla had to develop an extremely advanced cooling system for the 50,000-ton press. This new machine also includes a smart mold separation system and a highly intelligent AI-powered quality inspection process. Even if another company had a 50,000-ton press, they couldn't copy Tesla's special process. That's what gives it the edge. Extra aluminum is trimmed off and recycled for future use. Each final part is then inspected with X-ray equipment to check for strength and overall quality. One of the hardest challenges in the casting process is keeping the mold sealed shut during the metal injection. That's why these machines need so much clamping force, to stop the mold from bursting open. With a single casting cycle, Elon Musk said Tesla could make 5 chassis at once. XPeng's system can't do that. The 50,000-ton Giga Press can handle a huge amount of molten metal and pour it into molds for multiple parts in one go. Then it cools the metal, trims the extra material, and delivers a finished part with almost no human help. Its 500,000 kilonewtons of pressure allow for large molds that can create several parts at once, which means much faster production and lower costs. In contrast, XPeng's 16,000-ton machine, with 160,000 kilonewtons of pressure, can only cast one chassis at a time. But with greater power comes greater complexity. The 50,000-ton press will need a super-efficient cooling setup and high-level automation to keep product quality high. The bigger the casting machine, the more accurate everything has to be. Aluminum must be injected at the perfect speed. If it's too fast, bubbles can form. Too slow, and the metal might start to cool before filling the mold fully. On a 6,000-ton press, around 80 kilograms, 176 pounds, of aluminum is injected at 10 meters per second. The 50,000-ton version uses much more aluminum and must inject it even faster. Getting this technology into Tesla wasn't easy. Elon Musk's idea felt ahead of its time. Car factories used to rely on metal stamping and welding hundreds of parts together. Most die-casting companies thought Musk's idea was crazy and turned it down. Out of 5 companies Musk reached out to, none were willing to take the challenge. As a last shot, he contacted Idra. They didn't say yes immediately, but they said it might be possible. And for Musk, maybe was enough. Tesla and Idra then worked together for over a year. It wasn't smooth, Tesla kept asking for changes, and Idra had to keep up. But in the end, they made it work. The Giga Press was real, and it worked. So how much does each type of Giga Press cost? This matters a lot for whether die casting becomes standard in EV production. The 6,000-ton machine costs around $6.48 million. It offers 60,000 kilonewtons of pressure, making it good for small projects. The 9,000-ton version goes for $9.72 million to $11.34 million, offering 90,000 kilonewtons, enough for medium-sized vehicles. XPeng's 16,000-ton system costs about $17.28 million to $21.6 million. The 50,000-ton Giga Press. It's expected to be priced between $43.2 million and $64.8 million. That's 2 to 3 times the price of the 16,000-ton version, but it can cast 5 chassis at once, which speeds up production and saves money over time. The 50,000-ton Giga Press isn't just a machine, it's a symbol of a new age in car building. Its ability to cast 5 whole car bodies in one shot means lower costs and lightning-fast production. Compared to XPeng's tech, which can only do one at a time, Tesla's machine is miles ahead in scale and speed. Don't get me wrong, hypercasting is a big step for China's auto industry. But Tesla is taking things further. With advanced automation, integrated software, and full control over hardware and logistics, Tesla is shaping the future. While XPeng is still testing, Tesla is already producing at scale. Just like Ford changed history with the assembly line, and Toyota with lean manufacturing, Tesla's 50,000-ton Giga Press is redefining what's possible in electric vehicle production. The question isn't who will catch up, it's who's brave enough to go this far, and this fast. If you want to explore more about Tesla's EV technology or TeslaBot, hit that like button and share this video. Don't forget to subscribe to AMP Drive and turn on notifications so you never miss what's next. Thanks for watching, and we'll catch you in the next video. Goodbye.